All righty. Howdy, folks. Howdy, howdy. So we're going to talk a little bit today about some of our more conic sections, another conic section. We're going to talk today about an ellipse, all right? So an ellipse is an interesting shape. So what an ellipse basically is say you have two set points. We'll call it point 1, point 2. And everything at these points is where all of our attention and energy is going to be focused. So we call that a focus. What an ellipse essentially is every point that is the same sum from the two. So if I were to take this length right here and this length right here, and if I were to add them up, they would be the same length as it is to say these 2 points, this point right here. That the blue, if I were to add up both these blue lengths, they'd be equal to both the red lengths. Same thing if I have another point. Say, let's put this point right, let's make it right here. The distance from this point to both the foci would be, so the two purple line segments would be the same as the two blue line segments and the two red line segments. If we were to add them all together, they would both, all those sums would be the same. And if you were to take it and draw it all the way around, you get something that looks kind of like that. Mine's not going to be very good, obviously, and essentially I'm trying to draw this over here. You get something that is essentially what we call an ellipse, or some people will say a circle is a perfect ellipse, but it's curved like that. It's just, if you notice, where a circle has the same radius going out, this radius right here, the radius from here to here is not the same necessarily as the radius is from here to here. Although those two are. So you have two green radii that go left and right and two purple radii that go up and down. Now it doesn't have, it could be more narrow than it is flat like this. This is what we call a horizontal ellipse, but it could be a vertical one. It could have gone like this. An ellipse could also look like well, not quite like a potato, but I mean, you get the idea, right? It could have gone sideways, it could have gone vertical. So now there's different parts of these things. So, and what it is, and they're all based off the idea of certain lengths. So we say, let's see if I can actually kind of draw this a little bit here for you, at least highlight it. This length B, that's that length of that purple distance. So the distance from the center up to the vertical distance from the center to the top of the ellipse is your B value. The A value is the distance from your center to the horizontal outside. We call those vertices, or if it's a vertical one, those would be the co-vertices. So on a vertical one, the co-vertices would be on the left and the right, while the vertices would be on the top and the bottom. The vertices are always the points that are further away from the center. But even still, if I draw a center on this thing, the B value and the A value don't change. So this is still going to be the length of B. This is still the length of A. Yep. So A is your horizontal distance to the outside, B is the vertical distance. And then we have this weird little distance right here. I'm hoping you guys can see it. It's this other letter, C. That's the distance from our focus. That's called the focal length. It's the distance from our center to our focus. our center to our focus. So A is the distance from this center to the horizontal edge of the ellipse. B is the distance from the center to the vertical edge of the ellipse. And C is the distance from the focus to the center. Now, something you need to realize is that focus is always on the longer diameter. So it's always on the same side as the vertices. So on my vertical ellipse, I would actually have found my focus going up and down, because it's always going to be on that length going out to the vertice. And so that length right there, that would be my focal length. We'd call that C. A, B, and C. And friends, if we think about A, B, and C just a little bit here, right? If we think about, oops, I should have changed that out there. I made a mistake here, friend. A is always the distance on the longer diameter. I should have made that a little bit more clear. Notice B is always your shorter distance. A is always your longer distance. A always goes out to the vertices. So, but if you notice, we're dealing with three very familiar letters that are very familiar paired up together. We have an A, we have a B, and we have a C. And anytime you think of an A, B, and C, you think of Pythagorean theorem, A squared plus B squared equals C squared. But notice on this one, which one of those three is the longest side, A, B, or C? Well, A is. So therefore, instead of A squared plus B squared equals C squared, A is the bigger side. And so we would make the A the hypotenuse by itself. Or if we subtract the two squares, A and B, it would be equal to C. So we're going to call that our focal equation. So we're going to go down here. Now we know what A, B, and C are. Now we know what A, B, and C are. We're going to just look a little bit more. At some of the things that go with it. So, turns out it's going to have an equation very similar to our circle. If you remember, the circle was x minus h squared plus y minus k squared equals r squared. So what an ellipse basically does is it just says, hey, whatever that r squared was, let's divide by it. Whatever that radius was, let's divide by that number. So on a circle, when you divide by that number, you get a radius that's the same length going the horizontal distance as opposed to going to the vertical distance. But when you divide by it, the r squareds on the other side, they become 1. Well, that's the same thing here. So we're going to be doing the same thing that we did on circles, but realize the only difference is where circles had the same, the A and the B value, quote unquote, were the same radius. These guys' radii are going to be different. They're not the same value. So A will be our long radius, and B will be our short radius. So if a diameter is 2 times the radius, then our major axis or our major diameter is 2 times the A. Our minor axis or our minor diameter would be 2 times the B radius. And just like we said here, C is the distance from the center. So we have some points here that we need to make sure that we remember as we go through this here, friends. If I ever want to find my center, it's always going to be H and K. So whether it's horizontal or vertical, that never is going to change. Now the vertices on the horizontal, that's the A value going out left and right. So the vertices on the horizontal, that's going to be H plus or minus A. And they're going to have the same K value. For the foci, we're going to add and subtract C. And then we have our co-vertices. So our co-vertices, those are the shorter length. And on the short, that would be always our B value. And I added it to the wrong side, friends. Plus or minus B. Now, the vertical ellipse, same exact thing. So the center is still going to be H and K. It's just whatever I add A to is going to be the opposite. So for my vertices, since it's vertical, that means I'm going to add A to my K value, not my H value. For my F, my focus, I'm going to add the C value to my K value. And then the co-vertices, that's the B value, that's what we'll add to H. So it always is going to come back to first find your center, your H and K, and then figure out what A, B, and C are. And I know there's a lot of letters flying around here, and it looks a little confusing, but it won't be too bad. I'm going to actually show you how this works right now. So, all right, we're going to go through and play with all this. So while you guys are going through your notes right here, I'm actually going to go through. How do I enlarge that? How do I enlarge that, friends? That is the $100 million question right there. Oh, right there. There we are. I'm going to go into a different item. And go back to our graph paper here where it's just a little bit easier. So we're going to take all that information. I'm going to do your notes, but we're going to walk you through your notes, but we're going to use a different thing. So to begin with, though, that being said, I am going to add an extra problem to you. So that is too wide. So there you go, better. You guys are going to start off with this equation right here. So I'm going to start off and give you an ellipse. So this is the equation of ellipse. And what I want you to do is I want you to see if you can figure out the center, the vertices, the foci. It's not foci, it's foci. That's the plural for focus. Remember, we had a focus on a parabola. I want to know what the co-vertices are. I'd love to know the length of the major axis, the length of the minor axis, and I also want you to sketch the graph. So go ahead and take a second here and see if you guys can figure out all this information. While you're doing that, I'm going to draw myself a graph and put the equation back up here. I'm also going to need a graph here eventually, so I just throw that up here. All righty. Yeah, if you're still working on it, pause the video because I'm going to start moving on here in a sec, and then unpause it when you're ready. All right, so first thing we got to do is h and k. So just like before, the h is always going to be the opposite. Same with k. Already seen this on the conic form of a circle and on a parabola, conic form of a parabola. So we have our center that is -2, -1. So I'm going to go ahead and graph that center. Really, all you're ever doing on these, you're just counting a lot. So once you know what your a value and your b value are, you're just counting. So a is the square root of 25. It's the larger number, so that tells me that it's going to be going out left and right. It's a horizontal one. B is always the smaller denominator. So that means B is going to be 2. I'm going to go up and down 2. So when I'm saying I'm counting, here's what I mean by counting. Since my A is 5, I'm going to just go out 5. 1, 2, 3, 4, 5. Even though I gave you guys those little equations for how to figure out all the different points, I don't ever remember them, friends. There's no reason to. We're just counting. And then I'm going up 2 and I'm going down 2. So I know it was kind of a bad little one right there. The vertices will always be the length of the larger one. So I can go ahead and deal with it. I know what these points are now, so I just got to go back to my graph and just figure out those coordinates. I don't actually need to remember the formula. I mean, you can if you want to. It doesn't really do much for you. So -7, -1, and 3, -1. The co-vertices were -2, -3, and they are -2, +1. So we just count, and then you come back and get all your information you need. The major axis is always 2 times 8. So my a value was 5. So 2 times 5, that would be 10. Notice, it doesn't take very long to do these. They look kind of confusing when you first see them, but they're really not bad at all. 2 times b, so 2 times 2, that's going to be 4. So now we get to the one, if there is a tricky part, this is it. Can you find the foci? So remember that c squared is always a squared minus b squared. Whether it's horizontal or vertical, doesn't matter. So this was a horizontal one right here. No matter if it's horizontal or vertical, this always remains the same. So a squared, that was 25. B squared is 4. So c squared is 21. And if I take the square root of both sides, friends, I get c is the plus or minus square root of 21. So the foci are always on the same distance as my vertices. So the long is on the major axis. And root 21, I don't need to know exactly what that is, all right? And so I don't need to plug into my calculator and get the exact number. I know it's the square root of 16 is 4, and the square root of 25 is 5. So I know it's going to be somewhere in the middle, around 4.5-ish. I mean, the reality is these are all rough sketches anyways. 1, 2, 3, 4. So it'd be right about here would be 1, 2, 3, 4, right about here somewhere. But notice, I added and subtracted that c value from my center. Well, that's how we're going to write it too. I'm going to take my center. Now, we're not horizontally, so that's where my plus or minus root 21 is going to be. And the k value stayed the same. Last thing for us to do, friends, is just play connect the dots. So we're just going to round it a little bit, like a little flattened circle. There we are. Add a little sound effects there, friends. You'll be much more enthused and enjoy what you're doing there. And we have ourselves a graph. Well, I'll tell you what, I think we guys should try one. So let's try that first one on your notes now. That was a little extra one I wanted to throw on there just to make sure that you guys kind of get the gist of this here. So notice this one right here isn't written for you in standard form. You're going to have to complete the square to do it. So don't forget to complete the square. All right, so this is your problem. All right, why don't you guys just pause the video? And all I want you to do on this one is just complete the square. Let's make sure that we do that right. Because if we don't complete the square right, it doesn't really matter what else you have going on there. All right, I'm gonna go, while you guys are doing that, if you haven't paused the video yet, I'm gonna go ahead and just deal with this one as well. I never did write the equation of the vertical one up here. All righty. So pause, go ahead and pause the video here while I'm gonna go ahead and start to erase some stuff. All righty, friends. All right, so before we go too far, like I said, we're gonna just make sure we complete the square correctly, just like we did with the circle. So the only difference is we're gonna have a number now in front of the x squareds. So we're still gonna group up all our x's. And remember, when we group them up, I told you when we were doing circles yesterday, always put a plus in between your parentheses. That's gonna become important for the conic section, the last one we deal with tomorrow. Oopsies. That'd be a 40 right there. That's a plus 40. And that 37 got moved to the other side. All right, so now we're going to factor out our 9. So x squared minus 6x plus, and we're going to have to figure out what that number is that goes right there. So we're going to complete the square to find that. So y squared plus 10y. And we're going to complete the square to find this one too, like there. And we have negative 37 plus, plus. Now, when we go and do this, there's going to be a little trick here when we multiply this over. So we'll talk about that here in a second. So we're getting ourselves our graph here. We're going to complete the square here real quick. Let's see here. I have an x squared. I have a negative 6x. I don't have a negative 6x, friends. Come on now. If it's a square, it means I have to split in half. Some of you guys are doing the shortcut on this. That's great too. Just middle number divided by 2 squared. For my visual friends, we're just going to draw that visual out so we see it. So that number that we're missing here, that number that's missing here is the number 9, a positive 9. So we're going to add a positive 9 in. But remember that this isn't just a positive 9. We had a 9 on the outside too. So this positive 9 really isn't a positive 9. It's actually a positive 81 because it's a 9 times 9. We're not just adding a 9 to the other side. We have to add in 9 times 9. And friends, we've got another one here we got to deal with as well. So let's just draw our square for that one. So we have our y squared. We're going to break our 10y in half, so positive 5y, positive 5y. y, positive 5, positive 5. And then that gives us a 25 down here. So we're going to add that in up here. So again, remember, it's not just 25 we're adding to both sides, it's 4 times 25. I need to bring that 4 with me. So friends, now we're going to combine our like terms. So negative 37 plus 81 plus 100. And when we combine them, we get, well, first of all, on this side, 9 times x minus 3 squared plus 4 times y plus 5 squared. You can kind of gradually, slowly start to see this pop out here. When we add it to the other side, you get 144. So now we have our equation that would have been a circle, but if you notice, they have different numbers in front of the parentheses, so it's not a circle. That makes it an ellipse. So we are going to then set that side equal to 1 to get our actual equation. So our new denominator is going to come from simplifying this fraction. Simplifying this fraction. In other words, you take your numerator and divide it into your denominator. It will go in. So 144 divided by 9, that goes in 16 times. So that means I have x minus 3 squared all over 16 plus y plus 5 squared. 4 goes into 144 36 times equals 1. All right. So is it a horizontal or vertical ellipse? Got to be vertical because the bigger number is underneath y. So that means that's going to be my a squared value. All right. From here, go ahead and pause it now. And some of you guys, you may have had the right one. That's awesome. But if you didn't, no harm, no foul. We have the right one now. Go ahead and pause it, and let's see if we can actually graph this together. Go for it. All right, let's see how we did here, friends. Let's see how we did. Our center, opposite of x, so negative 3 is a positive 3. Positive 5 is a negative 5. So we're going to go ahead and put our center out here. So 3, 1, 2, 3, 4, and 5. 3, negative 5. We're going to go ahead and graph our vertices and our co-vertices. So here's my b value. Since that's a smaller number, b is 4. My a value is right here, square root of that number, so that's 6. Since it's underneath the y, bigger numbers underneath the y, I'm going up and down 6. So 1, 2, 3, 4, 5. Literally, we're just counting. 1, 2, 3, 4, 5, and 6. The right 4, 1, 2, 3, 4. Left 4, 1, 2, 3, 4. That means our foci is also going to be up and down, so we can go ahead and deal with that now. So vertices, I'm just going to go and get my coordinates of those. I had 3, negative 11, and I had 3, 1. That's 1. My co-vertices, I had a negative 1 and what is that? Negative 5. And I had a 7 and a 5. All right, major axis, not to be confused with Major Tom. All right. Ground control still looking for him. All right, so 2 times A, so 2 times 6. That was major tom, my bad. Great song, though. I was up in Tahoe this summer with my wife, and we heard a street musician playing a rendition of that song that was just gorgeous. All right, 2 times 4 is 8. All righty, friends. Now we're going to go ahead and get our foci. So c squared equals a squared minus b squared. So c squared equals a squared is 36 minus b squared, which is 16. So c squared is 20. So that means c is equal to a plus or minus square root of 20, which again is, I'm going to just, it's about 4.5, maybe might be 4.6. Who knows? It's around there somewhere. Not really worried too much about it. So, but this time I'm going to add it to my k value since I'm going up and down. So 3 comma negative 5 plus or minus root 20. So 1, 2, 3, 4.5. 1, 2, 3, 4.5. All right. And we play connect the dots, friends. It's a bigger one here. There's our ellipse. Hopefully not too shabby on that. Okay, hopefully not too bad at all. So let's go ahead and clear out the drawings here a little bit. And we're going to go back to our notes here. All right. What if I ask you guys to come up with the actual equation for it? So let's go ahead and pause the video and see if you guys can actually determine the equation that would have this information. All right, let's see how you guys did, shall we? Let's see here. And draw my axes on here. Because I'll be honest, I don't do anything until I've actually graphed it. So my vertices, I'll do those in red. So 5, 6, so 1, 2, 3, 4, 5. Three, 4, 5. 1, 2, 3, 4, 5, and 6. 5, 6. All righty, and 5, negative 4. I'm going to go down 4. Okay. So those are my vertices. Now, to try to figure out where my center is, I know my center has to be halfway between those 2 points. So in order to figure out where that center is, essentially I'm just going to find the average of them. Well, 5 and 5, I know the average of that. That's 5. So the center then, it's got to be at 5, but the y values, I need to find the average of that too. So I'm going to average those together. So 6 plus negative 4, and I'm going to divide it by 2. So my center then is going to be at 5, 1. And we could have done it graphically too. You could have just looked at this and seen. So that tells me then, friends, that tells me that my A value, first of all, it's going to be underneath the Y, but my A value is 5 units away. If we keep going here, I'm going to go ahead and use blue then for my foci. So 5, 4. 1, 2, 3, 4. That's going to be 1. 1, 2, 3, 4. It's 2 below there. There we go. And 5, negative 2. Well, that'd be right about here. There's my foci. And remember, that's my C value. So my C value then is 3. The only value I don't know is my b value, so that's going to be, again, c squared equals a squared minus b squared. And we can use that now to figure out our equation. So c squared, that was 3 squared, equals 5 squared. How would you play 5 squared? You could play 4 square. I could play 2 square. Even seen 9 square, but 5 square, how would that be? Maybe not possible. So negative 16 equals a negative b squared. So that means 16 is b squared. Now I don't have to say what b is. I mean, if I wanted to graph it on my graph, I could. B is 4. I'd go left and right 4, but I don't have to do that. So I'm not asked to graph it. I'm more asked to just deal with the equation. So this is a vertical ellipse. So a vertical ellipse, so that means the b is underneath the x. The a is going to be underneath the y. And we are trying to now plug everything in here. So if I know my center is 5, 1, I can plug that in here. So x minus 5. And I have y minus k, and the k value is 1, so y minus 1. B squared, that was right here. So b squared is 16. If a is 5, then a squared would be 25. So there is our function. All right, we got one more to go here. So let's go ahead and take a look at that last one here. What happens if I try to give you something a little bit more? An architect wishes to design a large room 100 feet long. So 100 from this value to that value. Okay. So if it's 100 feet long, the ceiling of the room has a cross section that is an ellipse. Okay, so this is an actual ellipse. So if the foci are to be located at 32 feet to the right and to the left, so you can kind of see those right. I'm gonna make them a little bigger. Okay, so this tells me it's horizontal. It's a horizontal ellipse. Not that I really needed to know that, but I can. It says determine the height. So I'm trying to figure out what is the height of this picture. What is the height of this arch? Well, the height, that means the height's on the co-vertices. That means it's the minor axis. That means it is the b value. And you can kind of see the b value written in there. I'm going to make it a little bit bigger. So our a value then is the distance from the center to the vertices. So a then is 50. And we have our foci, that's the distance from the center to the focus. So C would be 32, and you can see that on the other side there, that it's 32 feet. So all we got to do is figure out what B is. We're going to use our equation, our C squared equals A squared minus B squared, and we can figure it out. So C squared equals A squared minus B squared. All right, so C was 32. A was 50. And we're looking for B. So let's see, 32 squared, that's 1,024, and 24. 50 squared, that's 2,500. So when we subtract them, we get a negative 1476 equals a negative B squared. So 1476 is B squared. And now we go ahead and take the square root of it. Don't need to worry about negative here. We're just using the positive because this is an actual length. So the square root of 1,476 square feet. Not square feet, just feet. And some of you are like going, yeah, if you tell me to do a square root of 1476, I don't know what that actual dimension is. So we can actually go ahead and figure it out. So that B value, that height, would be about 38. We always go to 4 decimals, so 4187 feet. And there we go. That's our third conic section. That is an ellipse. All right, folks, good luck on that. And I will see you guys in the morning and we'll talk more about it.